Hello, everyone. Thanks for joining me for this session on how I reused some old smartphones to monitor some 3D prints that I was doing, and using some cool technologies, WebRTC, WebSockets, and also serverless containers. So I wasn't expecting that many folks for a fun little project that I did on the side. But thanks for being here with me today. So my name is Guillaume Laforge. I'm a developer advocate for Google Cloud. So there will be a bit of Google Cloud involved because that's the place where I could deploy my code and get it running for free. And I'm a Java champion. I'm also the co-founder of the Apache Groovy project and one of the Cast Codeurs podcast member and co-hosts. So you might know me for one of these things, maybe. And I'd like to tell you a little bit about this story that led me to be here on stage today with you. So how it all started? It all started with a 3D printer. So I watched, I knew lots of folks who were 3D printing stuff. Like I had my nephew who was doing some cool stuff with it. I was like, maybe I could print some useful things. And at some point, I saw a nice video from a YouTuber on a channel called Heliox, and the lady on that channel was reviewing. So she's doing tons of great videos on 3D printing, and she did a review of a 3D printer from Anycubic, the Anycubic Viper, and it looked like an interesting printer, so I bought it. And there are some cool, the fun thing, by the way, is that the stuff that is printed there on this printer hasn't been printed with that printer because there's only one plastic going through, so you can't have white and black at the same time because there's not double extrusion going on. Well, anyway, so we know it's a fake screen. Well, they cheated a little bit. But there were some nice features in that printer, and that's why I bought it. But you'll see why I'm mentioning the features of the printer. So there were things like auto-leveling, so it knows if the... I actually don't know the vocabulary for 3D printing, the level where the plate... Yeah, the bed, on the bed, if it's flat and everything. So it's automatic. I just click on a button and it's going through the leveling itself on its own. So you don't have to, like before with older 3D printers where you were putting like a sheet of paper to check if it touches, but not too much, etc. It was super easy to build, so just a few screws, stuff to put together and a few screws. That was fairly easy. There was a nice little touch screen instead of the usual rotary button and such. There's a spring steel platform, so it's easy to remove the prints once they are done, etc. So a really nice little machine that does some nice prints. But one of the features not listed there, and a feature that is not supported, is Wi-Fi support. So for example, there are 3D printers, which allows you to connect to the 3D printer from anywhere else in your house, etc., and check what's going on, what's the status of the print, or there are 3D printers, I think, that can also do things like recording time lapses of the print, because printing in 3D can take quite a bit of time, and you'll see on TikTok or whatever, lots of folks publishing their prints, so it's funny. But yeah, this printer doesn't have Wi-Fi. Okay, remember this for a little bit later. So some of the stuff that I printed, you might be thinking that I'm loving support and things like that. I built a support for, so this device is not really a LED display, but it's for displaying pixel art. And there was just a small leg behind, and it was pretty flaky, and it could easily fall. So I built something, I created my own thing to support this little screen. My daughter just got some new markers, and she wanted something to put her markers on. So that was fun, but I had to adjust to the right size. So I measured the markers and everything, but I had to do lots of trial and error to find the right shape, because it wasn't like square or round, so it had a special shape. So I had to come back and forth to my printer and try different layouts and shapes and so on before I succeeded. What else? I got a new stand-up desk, and I wanted to have I've got a huge wide monitor, so I don't necessarily want to look at the screen of my laptop, so I wanted to just put my laptop vertical, in a vertical position, so it doesn't take too much space on my desk. And what else? Oh yeah, it's not advertisement because I'm working for Google, but I have a Google Home Mini in my bathroom, and it's on the top of some furniture, and it doesn't always pick up the voice. So I thought, okay, perhaps I should put it in a different position. So I put it vertically again, and now it hears me much better when I say, okay, play the next song or something. It works much better. So yeah, I printed lots of cool stuff. But sometimes when you 3D print. I'm not sure it's very readable there because my picture is not of super high quality, but sometimes some prints take a fairly long time. So here, I forget what I printed there, but it took 16 hours and 39 minutes for printing whatever I was printing. So it takes quite a while. Not only that, so you'd like to know when it's finished, if it's progressing nicely, okay? Because sometimes what happens is that either it looks completely ugly or it fails completely because perhaps it was missing some support, and then it doesn't adhere to the bed, and the print goes completely haywire, and it's going to waste hours or meters of PLA filament. And you'd better stop the print when you notice that. So it's important to monitor your 3D prints, especially when they fail. And so, for example, another thing that I built for my daughter, she wanted something for little post-it notes and so on. So I print some stuff, and sometimes I like to take pictures of my prints and see, okay, what's the current state of things, and at different levels of different time during the print. But the problem is that there are stairs in my house. So let's say a typical house like this with several floors. So I have a house where my desk, my computer, and everything is upstairs. Okay, but since a 3D printer takes quite a bit of space, it's a bit noisy. So I decided to put my 3D printer in the basement. But if you want to check the progress of your 3D print, you have to, go upstairs, go downstairs, go upstairs, go downstairs. So depending how confident you are with your 3D print skills and the abilities of your 3D printer as well, you may go up and down quite a few times. And my printer doesn't have any Wi-Fi connectivity, so I cannot check from a distance with a built-in camera or something what's going on with my print. So, okay, now what? What can I do? Is there a way for me to actually monitor those 3D prints? So what do I need for that? I would need some kind of camera, and of course some wireless connectivity, Wi-Fi, etc., to be able to stream maybe the video of what's going on the printer, something like this. Okay. So it was time to have a look at what's available, and there's this nice project called Octoprint or Octopi. It's actually using Raspberry Pis so you also have to have a webcam that is compatible with Raspberry Pis, but basically it's able to stream what's filmed by the webcam attached to the Raspberry Pi, and broadcast that so that can watch, for example, from my bedroom upstairs. And so I didn't have a recent Raspberry Pi I could use, and they are hard to come by these days because of circuit shortage and chip shortage and so on. And I also didn't have a dedicated webcam that I could use for the old Raspberry Pi that I had. But at least I checked on their website, and it was also compatible with my 3D printer, with the brand that I had bought. But yeah, so I don't have a recent Raspberry Pi, I don't have a webcam, so I continued searching a little bit. And fairly recently, there's this little camera dedicated for 3D printing that was released and announced. So it's the Beagle camera, or Beagle print camera. So it's super cute, looks like a little dog, and it's really super smart. So it's a webcam, of course, because it films the 3D print. It can stream the 3D print, so I can watch it from anywhere else. And it actually plugs into the 3D printer. There's on all 3D printers, there's a USB port, and you can actually plug this camera into the the USB port in order to even load 3D prints directly, because usually I have my SD card and I go upstairs and downstairs to put stuff on my computer on the card, then go downstairs, put the SD card back in the printer and so on. And it's pretty clever because it's able to change the G code, so the instructions for 3D prints, in order to move the head of the printer so that you can film the different layers of prints instead of having the head always in front of the camera. Well, there are downsides to that. Potentially, you'll have to clean the 3D prints a little bit more. But, well, that's a nice little thing. It costs, I think, 70 euros or something like this. So, okay, it's neither cheap nor too expensive. So why not? I could probably buy something like this. It's pretty powerful, I would say. And then I thought, well, I don't necessarily need to buy each and every cool gadget that I come across. So I thought, yeah, maybe there's another way. So I have some webcams at home, like security cameras, but I was like, well, I don't want to reuse one of those cameras because that's not their purpose. But thinking about security cameras, I had heard about this app called Alfred, but there are other similar apps on the Play Store, on the App Store as well, which turns existing smartphones into security cameras, right, into IP cameras. So that's where I came up with the idea, yeah, I could actually reuse somehow an existing phone, smartphone that I have. Okay. And the other approach I could use, all these folks like Google Meet, Teams, Zoom, Facebook Messenger, etc. After all, okay, it's for conversations, but I could have my phone, I could chat with my 3D printer from my phone or my computer. That's kind of fun. But, there's some technology inside to do the streaming part. So I got all these things in mind, and then I thought, okay, why buy some dollar with some money, a solution, when as an engineer I can reinvent the wheel, right? It's usually fun to reinvent the wheel. So you don't necessarily build a super professional solution or anything like that, but still I was curious about how things like Google Meet, Facebook Messenger, etc., how are they handling video communication? So I was quite curious. So I started investigating a little bit in this area. And basically, so for this solution that I want to build, I need, of course, a camera. That's where the old smartphone will come up. Wireless connectivity. So I need to stream the content through a network wirelessly. I need to stream that video. And there are other little things that I might need, for example, a power source to power that camera, whatever it is, or a stand to have the camera in the right position for my 3D prints. So what about reusing old smartphones? So that's the idea I came up with. So if we review what we need, So some kind of camera, of course, all smartphones, even old ones, they usually have cameras. And I don't really care if it's high-level quality kind of cameras. I just need to, something to monitor what's going on. I don't need precise, pixel-to-pixel quality. Wireless connectivity, of course. Smartphones connect to Wi-Fi networks, so that's not a problem. For the little things, things like power source for, if I stream for 16 hours, I think the battery of my smartphone won't last as long, especially old phones. Usually the battery capacity decreases over time. And potentially other things like, a stand, and I could 3D print the stand for this smartphone as well. So it's a good use case, actually, for me. So what was left was the streaming parts. What can I do here in this area, right? So what kind of technology can I use? So that's the more engineering part of the story. So doing this little bit of detective work, this little exercise of finding what things like Google Meet and so on were using in terms of technology, the underlying standard or protocol they are using, and it's all of these folks are actually using WebRTC. So this is one example of an article that says, okay, here's the technology that's used in those products. So what is WebRTC? WebRTC is, so I'm going to highlight the key, so that's the WebRTC website. On the WebRTC website, so it says it's an open standard. So I like open standard, that's great. It's good for real-time communication, and indeed, I want to have a look in real time at what's going on with my 3D print. You can transfer video, voice, and data. Video, in my case, that's what I'm most interested in. And what was interesting was the fact that it was actually peer-to-peer, right? So my phone is going to connect to, for example, my laptop when I'm upstairs via a peer-to-peer connection. So it's not going, the video stream is not going to go through some server or something. That's interesting. And what else? It's supported by all the major browsers. And there are JavaScript APIs that I will be able to use from the web front end or the web pages that I'm going to build in my application. I could have used probably native applications, like build an Android application or something, but was more interested in a web-based solution. So that's why I was happy to see that, of course, all those web APIs, they all have JavaScript APIs available. So there's a web API for WebRTC. Plus other, we'll see that in the code. Plus other existing APIs, like to get the feed of a webcam or the camera built in your phone. But before telling you a little bit more about how WebRTC works and what we'll need to do in order to build an application that fulfills my need. So there are a few acronyms that you need to be aware of that are part of this standard. So the thing that can be problematic, it's when you have two devices that want to chat together. They need to establish a connection, but potentially, like my smartphone perhaps doesn't receive my Wi-Fi network at home in the basement, It's not the case, but it could be. Or let's say I'm going outside and I want to look into my phone, what's the other phone is filming or something. So usually you have to go through some NAT, network address translation, to establish the connection between two different networks. So you're behind some kind of NAT, some other kind of NAT, and then you both, since it's going to be a peer-to-peer connection, they need to contact each other in spite of being on different networks. So for that, there are different protocols that are available, let's say, through the WebRTC standard. There's, so I'll start with, so let's say I'll speak first about the servers. So there's a, no, I'll start with in the right order. So ICE, it's the Interactive Connectivity Establishment Protocol, which is part of WebRTC, which is about, okay, how are we going, the two peers, how are we going to chat together? So what's your IP address? Is it TCP, UDP? What kind of bandwidth do you have, etc. So that's called ICE. Then you also have another protocol for establishing the video connection. So it's called SDP, Session Description Protocol. It's about how, keep in mind the camera of the smartphone and then the browser capability, or if it's a bidirectional communication, it could be also the details of my camera, because they need to say, okay, we want to exchange video, but perhaps on the smartphone there will be some kind of codec, a video codec that's used and that's available. I can use that one. But then on the other hand, there's not a decoder for that particular codec. What else? Things like they will estimate the bandwidth between the two. So which should I be streaming in 720p or something else? So there are two protocols for the connectivity, one for the agreeing on the video format to use, basically. And then, because we need to cross NATs, there are two other things. There are STUN servers, Session Traversal Utilities for NAT. It stands for, well, it's a bit like, you know, those online services to, hey, what's my IP address, you know? It's a fairly simple server, and there are tons of freely available such servers in the wild that just allow two peers to know more about who each peer is and how to connect to each other, okay? So I'll need that. And there's also, but we're not going to need this, turn servers. So there are some cases, for some reasons, on some networks where when you're behind a NAT, you cannot necessarily connect to the other peer. So that's where a turn server, it's actually a server that has a relay, and that relays the video. But it's expensive if you've got several clients. I mean, it's something expensive to broadcast video to tons of clients at the same time. But it can be needed in some cases. In my case, that wasn't really needed. So how things work. So usually, so you've got the first, so I took some diagrams from the WebRTC documentation on the Mozilla website. So you've got, let's say, peer A is going to be my smartphone. It wants to chat with my laptop. And we're actually going, so peer A is going to contact the STUN server to get its own IP address, public IP address, not the local one on the local network. Same thing for peer B. And then once they agree and exchange some information, they can chat together. But the STUN server is really more just about the IP address. The right exchange of information is going to go through the signaling server, another protocol, but I'll come back to that in a short moment. But there are some cases where you actually need that proxy relay kind of servers. It's in the case of symmetric NAT, which disallow clients or peers, let's say, to connect to another peer if it didn't chat with that peer before. So it's impossible to discover each other and chat together, so you have to go through a relay server that's going to broadcast in every direction the video. So hopefully you're not in that situation, and I don't have a turn server, so that's okay. So we are more in this situation. But before we establish the peer-to-peer connection, we're going to do the ICE and SDP protocols. And it's going this exchange of, yeah, I can do this video codec, I can connect through that IP address. Those exchanges, that's the signaling protocol. Shouldn't say protocol, because it's not actually standardized by WebRTC. And so here's the exchange between the peers. So you can somehow forget about the turn server. That's when we need a relay. So basically, peer A is going to ask the STUN server, hey, who am I? What's my IP address? Then, well, if we were to use a turn server, it would ask a turn server, hey, I need a channel to relay my video. But otherwise, it's going to go through the signaling, it's called, on this diagram, it's called signaling channel, to say, okay, here's the codec I can use. Here's the size, the dimension, resolution, size, and so on of the video I can exchange. So it sends an offer, which goes through some server, and that's what I'm going to build. and send that to the other peer. And then the peer answer, so keywords offer answer that you'll see in the code in a minute. And then so they can exchange bidirectionally, and after a while they agree on which formats to actually use. And they do the same thing for the connectivity part. They say, okay, TCP, UDP, IP address, etc., several exchanges of information, and then they agree, and then we're good to go. We can establish the connection peer-to-peer, and we don't need the signaling server anymore. But this signaling server, as I said, is not, so it's described in the WebRTC standard, but it doesn't mandate a particular technical solution for this exchange of data, of information. So what can I use? Because it has to be somewhat real-time for exchanging this information. So I thought, but there are different ways to do that. I decided to use WebSockets because that sounded natural to use WebSockets, so bidirectional protocol. So I implemented my signaling using WebSockets. Then I found some samples, both in the documentation, and there was a nice article from someone who had implemented this in Node.js, so I started playing with the Node.js implementation. But being a Java developer, or Groovy developer as well, and also being a fan of the Micronaut framework, I thought, okay, I should probably build my own stuff, and I want to use Java and Micronaut. Then I also need to deploy my application somewhere, and since I work for Google Cloud, that was easy. I could just deploy that on Cloud Run. So just a few words about Cloud Run and Micronaut. So Micronaut, why Micronaut? Because, well, I know the creator personally, of course. But it's not a personal, relationship kind of choice. But it's more about because it's just great technology and you can get up to speed very rapidly. It's a very elegant framework. It supports several languages, Java, Groovy, Kotlin. It's natively cloud native. It sounds a bit cheesy, but there's a built-in integration for discovery, tracing, logging, etc. So since I'm going to deploy in the cloud, that's always a good thing. And the big thing going on for Micronaut is that it's using ahead-of-time compilation, and it's super awesome for fast startup time as well as low memory consumption. So there's no generation of bytecode, no dynamic class loading, nothing of that kind, no reflection, and that's why it's super fast and doesn't consume much memory. And also, although I didn't build it with Graal VM native image, but I might do that later on in the life of that little project, I can also create a native image so that it starts even faster and uses even less memory. And why did I use Cloud Run apart from the fact that I work for Google? It's because I can easily deploy a container, and the Google Cloud folks will handle the infrastructure for me. So I don't have. It's a fully managed solution. I don't have to worry about how it's running. I don't have to run my own server in my basement or anything of that kind. So that's less. Less headaches. Since you deploy containerized application, you can use any language, any library or runtime. I'm a Java developer, of course. I'm going to use a JVM under the hood. But there are also some features I was interested in. In particular, it's got some streaming support. So from the containers, I can use server-sent events. I can use gRPC, HTTP2, and WebSockets, which I wanted to use for signaling. And what else? There are some other features, custom domains, but I didn't use them. HTTPS, I know it's not super top secret, the stuff that I'm printing, but it's always good to use HTTPS. And there's also session affinity, especially the fact that we're going to do WebSockets. I want to, if there are several instances of my container running, I want to hit the same server all the time, instead of, I sent to the wrong one and I can't continue my WebSocket discussion. So I also enabled session affinity. So those features were interested for my use case. So let's have a look at how I implemented that. Or what do I do? No, let me show you first the demo maybe. So sometimes it doesn't work as expected on some networks. So that was a test I did earlier. So I'm going to use my phone. Okay, I need to create a new tab, and fingers crossed so it works. Otherwise, I might have to do it locally on my laptop. Okay, so now I can reload this one. So I hope it's going to work. Yes. So this is me. This is me. You're seeing me everywhere, but I can also show you yourself. Hello. So I can probably yeah. So I hope you're okay with being, because you know it's going to be on YouTube, right? So you're going to be on YouTube. Do I have to make you sign something, or I don't know? So yeah, that's the idea. Oh, perhaps I could show you as well, so what was in the, I've put plenty of logs. Yeah, so let's see, I can, stop that. You see the stuff that is exchanged. Let's say, so you're going to see, so the on message, that's my WebSocket on message. I'm going to show you the code. There's someone that sends through WebSocket a message saying, hey, I'm a broadcaster, I want to broadcast my video. And in return, I say, oh, I'm a watcher, I want to watch the video that's going to be broadcasted. And then that's where there's this exchange of information. So the stuff, so it's very small, and don't bother reading it. It's not really critical. But you can see things like, okay, I'm able to chat with over IPv4, etc. So there's lots of information there. I don't understand anything of this, and I didn't have to look at the details of this. So there's the that's the SDP part of the protocol where they exchange information about the codecs, the video format, etc. And then you're going to see candidate. Candidate, that's where we establish how we're going to do the peer-to-peer IP connection between the peers. And then once they are happy, so there will be offers and answers going on, ICE candidates, so that's a possible ICE connectivity, etc. And in the end, when the candidate is empty at the end, it means that the connection was successful. We don't need to exchange further potential connectivity information. So how did I build this? That's where we're going to look at this application. So this is, as I said, it's a Micronaut application that I built. And interestingly, I would say there's not that much to show here. So it's a controller that does the signaling via WebSocket. So to say that it's such a particular controller, I'm going to say, okay, this class is going to be a WebSocket server. And here's the path on which you can connect. Then there are a few things like, okay, I want to know who's the broadcaster among the different, because in a WebSocket connection, it's not just two client servers chatting together. There can be several connected clients. So I want to know who's the broadcaster and who are the watchers. And here, all sessions, that's going to be all the WebSocket sessions from those who are watching the video stream. So this is the session of the broadcaster. What else? Yeah, let's go down below. So there are three, let me do this. There are three methods on open when there's a connection that is established via WebSockets. On message, all the little messages that are exchanged, and then on close. So we just need to annotate those methods. On close when there's a disconnection. So let's have a look. Well, I can just show close. When it's closed, I get rid of the ongoing session, etc. Nothing really fancy. In the open method on open, I'm saying, okay, I want to save. I want to add that new session to my list of sessions. And so when the WebSocket is established, so here, remember, I'm in the middle. The WebSocket Micronaut application is in the middle. There are two peers. The broadcaster is going to connect to my Micronaut application via WebSocket. And so both broadcaster and watchers are going to chat through the Micronaut application. So that's why I'm going to say, okay, broadcast. So there's the broadcaster that sends a message. Hey, I'm here, I'm ready to broadcast. But I have to forward that message to the watchers to say, hey, there's a broadcaster who's ready to stream some video. And same thing, and then that's part of the on-message exchange. So there are two things. So I receive a broadcaster event. I'm going to, so for example, if there's a new broadcaster that may override the existing broadcaster, that's a potential use case. I'm going to resend a broadcaster message to watchers. When there's a watcher that says, hey, I'm a watcher, I also want to send that to the broadcaster. So I'm not sending that to everybody. I'm just sending that to the broadcaster to know, hey, there's a new watcher who's interested in that field, in that feed, not field, sorry. Then you've got the offer and answer. So offer and answer, that's where we establish the video exchange. And so there's a, how to say that? We're only forwarding that to each and every client, you know. So I'm not forwarding that to all the connected peers, but just the ones who want to offer an answers between the broadcaster and one particular client, because there could be different capabilities, video capabilities, etc. So that's why it's just on one particular session that I'm sending a message. Candidate, again, exchange of candidate, same thing in both directions. And perhaps I could just show you the message class. The message class is a pretty dumb record. So it's going to exchange the type. So you did broadcaster message, offer message, answer message, etc. The ID, I use the WebSocket session ID as an identifier. And description, that's the weird, you know, things like this that you saw exchanged in the logs that are exchanged, that are in that description field. So that's all. But what's interesting is that really this Micronaut application is here only for the establishment of the peer-to-peer connection. So it's really just in French, I would say passe-plat. I don't know how to say that in English. So it's just, you know, passing data around. But there's not that much smart in that application because it's just for establishing a conversation. And then the WebRTC protocols are doing all the rest. There's actually more code in my two JavaScript files. So there's one for the watchers and one for the broadcasters. So let's start with the watcher. We can instruct the WebRTC JavaScript API to say, okay, I want to access the Stern server. That's the one where, hey, tell me what's my public IP address. And you can specify also private ones, etc. And then I'm going to establish a WebSocket connection to my Micronaut application. I want to retrieve, so there's a video tag in my HTML. So that's where I'm going to display the remote stream. And then it's similar to what we had in the Micronaut application in the sense that we've got an onMessage method in JavaScript as well on the client side, and it's going to send broadcast, offer, etc. But what's probably more interesting here, perhaps I'm going to explain, let's say, yeah, this part, I guess. So these like classes like RTC peer connection, and all these, well, those methods like create answer, create offer, set local description, set remote description, that's how the connection or the data, the data formats of video formats, information, etc., are going to be exchanged. So this I didn't really invent it myself because I saw it in some samples and in the documentation. So I wouldn't have guessed exactly how this API was supposed to be used, but fortunately it's well documented. And basically, it's establishing the RTC peer connection. And so when there's an offer and answer to exchange the video format information, it has to set the local description of the SDP that is local and the SDP information that is remote. So that's why we're saying things like set local description, what I have locally, and where's the set remote? Yeah, and set remote is right up there, saying, okay, here's what I received through WebSocket about the possible video exchange information. And what else? On track, so that's when the peer is adding a video track to when you use the user media APIs of navigators, of browsers. So you add that to the stream, and you're going to play the video as soon as the video stream is available. What else? So ICE candidate, yeah, I don't necessarily need to dive deeper in that. So similar things for SDP, now for ICE information for the connectivity. So I tried different things because at times I have some issues. So I wasn't sure what to use. And on the broadcast side, it's pretty similar code, except, so I'm going to show you like the code at the bottom, which is, yeah, here. So here I've got some function that's fetching the different cameras that are available. So for example, on my smartphone, so this is not an old smartphone, but on my current smartphone, I have two cameras, rear and front cameras. So I want to be able to select the camera I want to use. And the other interesting part, it's here. So if there's video capabilities, I want to be able to I'm interested in the video feed of that camera, and that's what I'm going to add later on. I think it's here, where I find the video that I want to send. Well, that's roughly it. Is there anything else I need to tell you about this? No, that's pretty much it for the code. Then, since I'm using Micronaut and deployed on Google Cloud, I did a few configuration things like properly configuring the logging. I was using Jib, perhaps you might have heard of this, for creating the compiler out of my code. So the Docker container, and deploy that on Google Container Registry, Google Cloud Container Registry. And then Cloud Run is going, well, I've got some commands here for the kind of commands that I've been using to deploy stuff. But well, it's not very important. All right, and yeah, I could also show you the Google Cloud Console, so I can see the kind of information that are exchanged as well when I look at the logs that are printed from the WebSocket implementation in my Micronaut app. And yeah, that's basically it. All right, so let's get back to the slides. So in summary, that was pretty interesting to learn about WebRTC, because I had never used WebRTC. Well, as a user, as a consumer of WebRTC, of course, I've used WebRTC when I use Google Meet for my, business meetings and team meetings and so on. But I never actually tried this web API, so it was fairly interesting to understand what it was about, how it works. Although some stuff is still pretty mysterious, and especially when, for some reason, I don't see the video stream on the other end. I'm not always sure why it's actually not working. So is it a NAT problem or some big wireless network, Wi-Fi networks? Sometimes they have some security built in to avoid peer-to-peer connectivity and that kind of stuff. So that's quite mysterious, and I'm really not a networking expert and not a WebRTC expert. The other thing that was interesting was that when I build web apps, often I'm going to do some classical AJAX stuff, but WebSockets, beyond just implementing a chat app on WebSockets, I've never used WebSockets for real in an application. I've been using AJAX kind of calls from my web apps, but that's about it. Or I had to use server send events when I was, never mind the details, but just receiving, but it's not bidirectional, so I was receiving some feed of data using server send events. But yeah, WebSocket, that was the first concrete use case where I needed to use WebSocket. And WebSocket is fairly straightforward to use. So this is just a proof of concept that needs some improvements, because as it is today, there are some issues. So for example, after a while, perhaps I can show you. Does it still work now? Yeah. So no, I switched the phone off, and for example, if I go back, let's see if it works. I think it won't work because I need to work again on this. Let's see. Perhaps I'll need to reload. No, it's still working. But there are some cases, so I forget exactly, but there are some cases where it doesn't work. So here I reloaded both apps, but if, for example, here, Yeah, so it goes away now. Well, there are some cases where it doesn't work out of the box to reconnect. So there's the WebRTC connection that is established between the peers, but my Cloud Run instance running my Micronaut application stopped running because there's no more exchange, SDP exchange, ICE candidate exchange. So the sessions are terminated after a while. So they need to re-establish the communication between the peers through the signaling server, because it's not going through the WebRTC protocol then. What else? So it wasn't that trivial to get right, especially with the WebRTC part, but fortunately there's some good documentation online. So next, I'm not sure what to do, whether I should continue this. You know, it's just a demo, basically. It's not a very complicated thing. And if I wanted to do something more reusable that others can use, I should probably make something more solid. So I'm not sure what I should do, or if I should, you know, play with some Raspberry Pis for fun, or if I could perhaps buy this nice little dog-looking camera, which was fun as well. But so I'm curious what you think about this potentially. And I also I'll publish the slides on Twitter. I think there's my Twitter account there, @Guillaume Laforge. So if you want to get access to those links. And yeah, that's about it. So thanks for your attention. And we have 5 minutes for questions. Thank you. Any question? What? The slide with the links? Yeah, I can show you if you want to take a picture. So you don't have to follow me on Twitter. And it's okay, it's okay. And if you've got some, if you're filming your own 3D prints, I'm curious what you're using. So don't hesitate to come to me and chat with me afterwards.